Hi everyone, this is Greg Ilg with Renaissance Electronics America, and today I'll be giving you an introduction to two software development tools for the RX family of MCUs, the RX Code Generator and the RX Fit Configurator. But before we get to those, I'd like to show you what would be required of engineers developing without those tools. You would begin by going to the hardware manual for that MCU. In this case, I am looking at the RX 113. And let's say we'd like to develop a UART driver. That would require the Serial Communications Interface peripheral. So we go to that section and begin to look at the spec. And we can see that this particular peripheral is capable of operating in several modes. Asynchronous mode is the UART mode, but it could also be configured to run in clock synchronous mode, smart card, I2C, SPI, and so on. Then the engineer would have to go through dozens of pages to learn the difference between these modes, the registers that have to be initialized, and so on. And this could be a time-consuming process. You have to learn the peripheral, write the code, test the code, and debug it. But for many, this was the only option available. Another approach would be to find sample code on the web. So let's begin by going to the company website, renaissance.com. And in our case, we are interested in RX applications. And as you can see, there are 449 sample programs. Now, you can narrow down this list by applying filters to something more specific to your needs, or you can just scroll through them one by one. And if you happen to need, say, a USB speaker demo for a 231, or a sensorless vector control program for an ARX24U, you're all set. You can download these programs and modify them to meet your specific needs. However, often what you're going to need is parts of several different programs. And cutting and pasting drivers from different programs are not guaranteed to play well together. For one thing, they may have been developed using different clocks, and that alone will make them incompatible. So, what are our alternatives? Well, let us begin with the RX Code Generator. I have already created a project using this for the RX 113 and for the SCI UART interface. In a Code Generator project, you will see a folder called Code Generator, and in here is the Peripheral Functions folder that lists all the peripherals available to the MCU. For example, if we wanted to configure the clock generator, we would click on that, and a dialog would open up that gives you radio buttons and combo boxes for everything that you need to configure. And we were looking at the Serial Communications Interface. We click on that and we can see a tab for every channel available on the RX 113. SCI1 is a channel we would be interested in if we were using an RSK 113. The Settings tabs provide you with all the radio buttons and combo boxes you need to initialize that peripheral. We would click on Generate Code, and code would be added to your project. Now this I've already done. In this case, we're going to look at the Renaissance Code Generator SCI.h file. Now the majority of this file just contains equates needed to program the registers. And at the end of this file, you will find the API available for your application to actually make use of. Now if we look at the driver itself, the code that is generated, we will see that all those equates from the .h file are hard-coded directly into the registers. These are not passed by value into the functions. This makes for very fast, very efficient code and a very small footprint. The disadvantage of this, however, is that if you need multiple channels, you would go down here, select the other channels you would like to run on, set up the configuration as you would like it, again, generate code, and another copy of the driver would be created. So if you wanted 2 UART channels operating, your driver would double in size. That is a slight drawback. But for most people, however, if you just need a single channel, small footprint, high-speed operation, the Code Generator is the way to go. If, however, you need something a little more powerful and a little more flexible, then you'll be interested in using the Fit Configurator. Now, FIT stands for Firmware Integration Technology. That means all of the drivers are compatible with each other, guaranteed to work, and as also they are guaranteed to work across MCUs so your project becomes portable. And similar to the code generator, you will see a list of all the drivers available to the MCU. You select the driver you're interested in, add it, and it will appear over here. And you can see the specific pins available for each of those drivers in this column, and you can configure those here. Click Generate Code, and the driver is added to your project. Similarly to the code generator project, you get a .h file. Here you have an if.h file, which stands for interface file. Here, instead of having values that are coded directly into registers, you get values that are passed into functions. And also at the end of this file are the API functions that your code would make. And as you can see, these have arguments passed into them instead of hard-coded directly inside. Now here in the main program, you can see an example of this, where the open call is passed all of these configuration parameters. And to set these configuration parameters up is fairly easy. Start with the config structure, which is the name of the variable for this API. I'm going to use the async call. I want to select the data size. And then when I want to come up with the value associated with it, I start out with the module name, the first few letters of the variable name, hit Control Space, see what options are available to me, and select. And as simple as that, I have configured the driver to run on 8 data bits. Also, let's say I want to now not just run this on one channel, but on 2 channels. So I just copy the open function, paste it back, set the channel, another channel I want to use, and I would also have to add a unique ID for that, a new handle variable. And right there, I have now configured the driver to operate on 2 channels. If I wanted to do the same thing with the code generator, I would have to go and select a second channel, go through all the combo boxes again, generate code, and I would have doubled the size of the driver. Here, all I have done is added an extra pointer to an extra set of control registers internal to the driver. So yes, by adding another channel, the driver size has increased slightly, but it has not doubled in size. This is the advantage of using the fit drivers as opposed to the classic code generator. Now this video was an overview of getting started with the code generator and fit configurator. For more detailed information, we've created separate code generator and fit configurator videos. You can also learn more by visiting www.renaissance.com. Thank you.